Before I talk about this map, let me just explain a little bit more as far as the interaction here with a hurricane moving to the north, often causing these outer rain bands to trigger tornadic activity. So what's happening is this warm, moist air, this tropical air, this huge weather event is moving through the Gulf, and it's oftentimes heading north towards the Gulf states, north towards the Atlantic coast, towards Texas, and then towards Oklahoma, towards the interior United States. And so as it's moving north, typically we see ahead of the eye, or to the northeast of the eye, or the path of the tropical cyclone or its low pressure center, we see tornadic activity. What's happening there is those spiraling outer rain bands are essentially quickly bringing with it warm, moist air that's colliding with the cooler and dry air that's just kind of hanging out there in the interior part of the United States. This is kind of minding its own business, and all of a sudden, boom, here comes this hurricane bringing with it warm, moist air. As I've talked about beforehand, those atmospheric lifting mechanisms, one of the ways in which we can produce rain is when we have frontal lifting. In this case, we have warm, moist air that's quickly colliding with cool, dry air. And so we get that uplift to quickly occur. That's the recipe for rapid uplift, which causes eventually that warm, moist air to condense, cool, and fall back down as rain. And oftentimes when that happens quite quickly, that's severe storms or possibly tornadoes. So here in this particular map of Hurricane Delta, what do you know on its path to the north and to the east of its particular path? Think of its path curving this way, and so to ahead of it and to its right you would see tornadic activity, and that was the case with Hurricane Delta. And so let's go ahead and we'll look into this particular area and try to understand a little bit more as far as what's going on in this particular area of Georgia just south of Atlanta. So just try to orientate yourself here. Here's Georgia, here's Atlanta. This is a loop here, so it's just going back and forth over time. Mississippi, Louisiana, Florida, the Gulf of Mexico. And so here's the path. So the path of the particular hurricane, and so its low pressure center, we're going to try to identify it as its loops here. And so the low pressure center is somewhere right about here, and it kind of dies out over Alabama as it shows here, over Alabama, southern Tennessee. So once again, we'll loop it. So it's looping. I'm going to follow it with the arrow. Okay, now it's coming back this way. So the low pressure center, where we're seeing that spiraling around happening, that spiraling right around there. Okay, so that's just kind of to orientate ourselves as far as this low pressure area where the remnants of Hurricane Delta are in this Doppler radar image, which is showing rainfall. And so what we have here coming from Florida, you can really see these winds coming up. If you kind of see, it's hard to see, but just look at these little dots that are going up. Those are convective clouds. These are convective storms that are coming from the south that really show that warm, humid air that's coming up in this direction. And so that warm, humid air. So we've got what we call wind shear. We've got wind coming in different directions. We got wind coming up this way, but then we also notice these spiraling rain bands are coming a different direction. And so it's here at the very end of this loop where those tornadoes are actually going to be triggered or shown. And so it's this little, at the very end, this last band, as this rain comes through, it's there where these tornadic activity happen. This is the radar image of the Hurricane Delta, and as it comes through here, you can see how the rain bands have extended outward. And so it's going to come through here and start to dissipate as it's moving across the southern Gulf states. I'm going to pause it right about here. And so it's at this very end. So it's right about here in this particular area of Georgia. Kind of watch what happens here at the very end. You can kind of see these pop-up storms right there, right through here. So here is essentially what caused a bunch of tornadoes in this particular area of Atlanta, of Georgia. And so that particular cyclone, it's still spiraling, looks like right about there, so the remnants of it. So we still have outer, this is still a band here, but it's obviously dissipated. It's nothing like it was beforehand. That clearly defined eye is way gone. But this is a good way to showcase, hurricanes. They can still do a lot of damage well after they make landfall. This is from the National Weather Service. It shows the remnants of Hurricane Delta, and this is from Peachtree City, Georgia. Cool jobs they've done as far as kind of quantifying and displaying the various tornadoes that were triggered from Hurricane Delta. So here, what's very typical of tornadoes is they vary as far as their widths. Some of them, 90 yards. Some can be, up to a mile wide, whereas others just a few yards. But their length can also vary. Some can be just a few feet, and others can be over a mile, several miles. As far as their wind speed, of course, can also differ as well. But one of the things you see here in this particular web page is most of the paths go kind of in a south to north trajectory. Traditionally, if you take a thunderstorms and tornado course, you would learn most of the tornadoes that occur in Tornado Alley here in the Midwest, the Great Plains, Indiana, have a southwest to northeast path. But in this case, hurricanes, they often trigger, in this particular part of the world, tornadoes that have a south to north path or even a southeast to northwest path, which you see here. And so these are ones that have a southeast to northwest path. This is a location of where a tornado started that generally went to a northern path, and there's a few others that were in this particular area. And this is from Hurricane Laura. So as Hurricane Laura kind of was moving through and kind of was in this particular area, it actually triggered a series of tornadoes in this particular area of the state. Once again, not over here, not way over here, but more, of course, towards the north and towards the east. Or to the right of the path is where we traditionally see most of the tornadic activity. Of course, this is way far away from a shoreline, so once again, the impact of a hurricane can be still felt way far inland as this particular large storm moves inland and dissipates. And to give you an idea of a tornado report, this is one from the particular previous Google Earth that shows the start of it. This was I just punched in the lat long there, and that's what that pinprick was. And it came 10 o'clock at night, and essentially was a EF2, bringing 115 mile per hour winds. Its length was 14 miles. That's a pretty long one, and its width was also 100 yards, so quite wide. Particular tornado, and then it shows its damage. Of course, toppling trees and toppling power lines, and many typical things like debris and from homes and trees and all those kinds of wind-related events.